Dear students, welcome. We are on the CEC Gurukul lecture and we are in the series of electronic circuit. In the electronic circuits, up to now we have discussed the many components which are used in the electronic circuit, like diode, like resistance, like transistor, like resistors. In the today's lecture, we discuss the rectifiers. Rectifiers plays also an important role in the electronic circuit. What is a rectifiers and how it works, what type of rectifiers are, that we will discuss in today's lecture. So first we see that what is the rectifier and what is the rectification. As rectifier is the device or which convert the AC current into the DC current. You are seeing on the screen that rectifiers are which convert the alternating current into the direct current. AC to DC converter is the rectifier. So when we convert the AC current to the DC, we use the rectifier. Basically, rectification is the process of the converting the AC to DC. For the rectifiers, we use the diode. Diode will conduct only when it gives the forward biasing, then we can get the AC convert to the BC. And here we have the anode is more positive than the cathode as we are taking the forward bias. Then AC is applied to the diode, it will conduct only in one direction and giving the DC current. Direct current we will get by the AC current when it applied to the diode, and it will conduct only in the one direction. So rectifier which convert the AC into DC by using the diode. Now what is a rectification? Basically, rectification is the process of conversion of the alternating current which is periodically changes direction. As we will know that alternate current is the periodically changes directions and it is like a periodic arrangement, and into the direct current which flow in a single direction. So rectification is the process of conversion of the alternating current into the direct current. Now the types of rectifiers are classified into the two parts. One is the single phase rectifier and the second is the three phase rectifier. In the single phase rectifier, again it categorized into the three form. One is the uncontrolled, second is the half controlled, and third is the full controlled. These are the basically the single phase rectifiers. Similarly here in the three phase rectifier, we have one is the uncontrolled three phase rectifier, one is a half controlled three phase rectifier, and another is a full control rectifier. So if we come on the single phase rectifier, then we will see the uncontrolled rectifier is also categorized into the two parts. Number one is the half and second is the full rectifier. So again the full rectifier divided into two parts. One is the central tap and second is the bridge. Bridge plays a very important role in the preparation of the devices. Like if we have the Wheatstone bridge, then we use this rectifier to get the output. And similarly here in the three phase, we also have the full wave rectifier and full wave rectifier and the half wave rectifier. Again here in the full control manner, we again it divided into the half and the full bridge. So these are the classification of the rectifier on the basis of the single phase or the three phase. Now what are the different type? The mainly we classified into the two type, control or uncontrolled rectifier. In the uncontrolled rectifier, this type of rectifier whose voltage cannot be controlled, means the voltage cannot be controlled in this type of uncontrolled rectifier is known as the uncontrolled rectifier. The uncontrolled rectifier divided into the broadly into two parts. One is a half wave rectifier and second is the full wave rectifier. Now the type of rectifier that converts only the half cycle of the alternating current into the direct current, that will be the half wave rectifier, where the only the half cycle of the alternating current convert into the DC. Likewise, a full wave rectifier which converts both the positive and the negative half cycle of the AC, because in the full wave rectifier, as we have a positive and negative cycle, then it convert the full cycle, both the positive and negative half cycle of the AC. An example of this is the bridge rectifier. If we talk about the bridge rectifier, then a bridge rectifier contains the 4 diodes that connected in the form of the Wheatstone bridge. So here we see that the half wave rectifier. How this half wave rectifier is this type of the rectifier that converts only the half cycle of the alternating current into the direct current is known as the half rectifier. You see on the screen that here we see that on the left hand side it is the AC current. Then here on the in between that you are seeing that there is a circuit, electronic circuit, where we use the diode. You see here the D is the diode which is used to convert the AC current into the DC current. Here we have the rectifier circuit, and you see on right hand side the output we are having the upper half cycle, means we are having the half alternating current cycle here in the output. Now the half wave rectifier, when we AC is applied to the power transformer and it steps down the voltage to the required AC. This AC is apply to the diode D1. You see here that we are using only the single diode, that is the D1. During the positive half cycle, the diodes gets the forward biased, because we are getting the positive half cycle, that is in the forward direction. In the forward biasing we are having the positive half cycle. Now the current flows from the anode to cathode. As we are taking the forward biasing, so we are using the anode which will move towards the cathode through the load resistance, that is represented by the RL. RL is the load resistance back to the secondary winding. So the current flows from the anode to cathode through the load resistance back to the secondary binding of the circuit. This the current second binding of the circuit, means here we are seeing that on the screen that the second binding, you see here the 2 coils are attached, 2 coils are separated with the 1. So through the load resistance we are having a diode and it will be attached here. So now the current flows from anode to cathode through the load resistance RL back to the secondary binding. This current produces a voltage across the load resistance RL. Thus, we can get the 1/2 of AC input as a output. Means first half, 1/2 of the AC input we will get as the output. During the negative half, the diode gets reverse biased. Now the diode stopped conducting. During the negative half, yes, this is very clear. Then we are having the 1/2 of the AC as a input at the output. And what about the negative half? The diode gets the reverse. Now the diode stopped conducting. So the diode conducts only for the 1/2 and gives the output of that half. Means when it is in forward bias and we are taking the positive part of the AC input, the negative will be reversed bias, so diode will stop conducting that and the output will be only through the half cycle of the AC. So output will be the half cycle. As the diode conduct only in the 1/2 of the applied AC, it is called the half wave rectifier circuit. This diode rectifies AC into the DC, but obtain the DC is a fluctuating DC and not the constant DC we will get in this through this rectifier. Now second is the now you see on the screen that this is also the half wave rectifier. You see on the left hand side here we are having a full cycle of the AC, and on the right hand side we are having the half cycle that will be the positive, because it is in the forward bias, current flowing from the anode to the cathode. You see on the screen, and here only using the one diode, and another positive negative is the battery and the load resistance we are using here. Now in the half rectifier there are some parameters where we are having a number of the diode required is the 1, transformer requirement is not essential, average value of the current IDC maximum and RMS value of the current 1 RMS and peak inverse voltage will be the V maximum. Here we are having the peak load voltage I maximum and load DC output voltage we are having. The rectification efficiency must be the 40.6%, ripple factor 1.21, fundamental frequency to the ripple F will be the voltage regulation will be the good, transformer utilization factor must be 0.2, form factor 1.57, peak factor 2. So these are the sum of the parameters of the half rectifier. Now again the half rectifier again subdivided into two parts, positive half wave rectifier and the negative half wave rectifier. A half wave rectifier that converts only the positive half cycle and blocks the negative half cycle, that is taken from the source and then you are taking the pic here from the website. That here we are seeing that on the left hand side input is the full and output will be only the positive, and the other one where we just have the forward bias, the negative half rectifier, input in the full form and output only the negative half cycle we will get. So it will be the positive half wave rectifier and the negative half wave rectifier. Negative half rectifier, a negative half wave rectifier converts only the negative half cycle of the AC into the DC. Positive will convert the positive half cycle and negative will convert the negative half cycle of the AC into the DC. Now in this type of rectifier, a half wave rectifier is the simplest of them all as it composes of only the single diode. See on the screen that here we are having a diode, we are load resistance, then the half wave rectifier. This is the battery. So a diode allows the current flow in the one direction known as the forward bias, and a load resistance RL is connected in the series with the diode. So it is a half wave rectifier. Now the full wave rectifier. In case of the full wave rectifier, which converts both the positive and negative half cycle of the AC alternating current into the DC direct current, it provides a double output voltage compared to the half wave rectifier. A full wave rectifier is made up of the more than one diode. And the full wave rectifier, we convert both the positive and negative part of the input of AC into the output. So both the positive and negative half cycle of the AC alternate current of the DC current will be provide the double output, double voltage we will get, other double output voltage we will get as compared to the half wave. Here we use the more than, you see on the screen that here we are using the two diode D1 and D2. Left hand side we are having that a AC circuit, AC input, and which is the full cycle. After that you see one diode convert into the half and another convert into the half. Then you see output, all the cycles is in the positive form. Full rectifier, negative and positive output we will get here in this full wave rectifier. Right hand side you are seeing there is no gap between the output, then we are giving all the output simultaneously. Previous one we are having on the positive. You see in the blue type it was a positive, and in the orange type it is the negative output of the AC input, negative cycle of the AC input. The full wave rectifier uses the two diode and a central trap transformer, and central trap transformer will be used in this type of full wave rectifier. Now in any transformer, the end of the secondary will give the output of the phase voltage. The voltage will alternating with one end at the higher positive potential than the other of the one half cycle, and at the lower negative potential during the next half cycle, and so on. First it will take the positive, after that it will take the negative of that, and then it will give the output of the another cycle. Now you see on the screen that this is a full wave rectifier which is having the which give the upper half cycle output, and during the first half the top end A gets the positive half while the bottom end B gets the negative half. D1 gets the forward biasing and D2 will be the reverse biasing, means one diode will be in the forward biasing and another diode is in the reverse biasing. So hence only the D1 will conduct during this half, because we are taking the upper part, means positive cycle we are taking, and it is in the forward bias, so only the output will be from the D1 part. D1 will be conducting. The current will not flow from A through D1 through a load resistance to the central trapping of the transformer. This produces a voltage with the positive polarity as we are having in this diagram. You see here, then only this part will give the output. This is another, you are seeing the left hand side we are having the full cycle and right hand side we are having the output. Now during the next half, the end A gets the negative half while B gets the positive half. Again here you see this will be the lower part, we will getting the lower part, that will be the output as a positive half. Now D2 gets forward biasing and starts conducting, and while D1 gets the reverse biasing and stop conducting. So does the current flow, the current flows from B through the D2 through the load resistance is in the same direction back that of the central trapping. Hence this half also gives a positive voltage as the diode conducts during the full cycle both of the halves. It refers to as a full wave rectifier, where we are getting the output from both the diode in the forward direction and in the forward biasing, and the one direction will get the output of the positive cycle as well as the negative cycle. Again, the full wave rectifier divided into the two parts. One is the bridge rectifier and second is the center tap rectifier. So in the bridge rectifier, you see as on the screen that there are the 4 diodes are attached. You see that in the circuit diagram, the 4 diodes are attached with the load resistance as well as with the battery. So this is the one type of arrangement here in the bridge rectifier. A bridge rectifier uses the 4 diodes to convert both the half cycle of the input AC into the DC output. Again, it is a full rectifier, so these 4 diodes will convert both the positive and negative cycle of the AC current into the DC output. In this type of rectifier, the diode was connected in a specific form as we are having on the screen. These 4 diodes are connected. Now this is the bridge rectifier. You see on the left hand side we are having input of the AC. Again the 4 diode, half and positive and negative cycles are transformed towards the rectifier, towards the diodes D1, D2, D4, and the output, the full output we will get through it, means for the positive and negative cycle both are as a output. The bridge rectifier uses the 4 diodes. The circuit has 4 balanced arms. It will be all the diodes are balanced, and it is called the bridge rectifier circuit. As before, when the secondary and A is positive going, the B will be the negative going. The positive voltage A is forward biased D1 and the reverse biased D4. And the negative voltage at B provides the forward bias for D2 and reverse biased at D3. means we are getting the output through this rectifier only in the forward biasing. So here you see very clearly, as we are using the 4 diode D1, D2, D3, D4. So in the first we are using the 2 diode, that will be the D1 and D4. D1 is a forward bias and D4 is a reverse bias for the positive voltage. Again for another 2, D2 will be the forward bias and D3 will be the reverse bias in the negative voltage, as we see. Now the D1 and D2 will conduct and the other half D3 and D4 will conduct. So in this manner we can get the circuit diagrams, can be omitting the non-conducting diodes for easier understanding. So during the first part the current flows from A through D1 through load resistance through D2 back to the secondary load. So here see that it will flow from the D1 and D2 it will be the back. Now during the next half cycle the current flows from B through D3 through RL through D4 back to the secondary. Now in both the cases the current flows through RL in the same direction, producing a positive signal as shown here, that we are getting the output for both the positive and negative. Thus the bridge rectifier also gives a full output. You see the D3 and D4 we are using. So now we are taking for the another cycle. So this is the bridge type rectifier. Thank you very much.